Hi everyone, and welcome to the 4.3 lesson video. Today we're going to be modeling with quadratic functions, and our objective is that we can model data with quadratic functions. So let's begin by talking about a little bit from lesson 4.1. When we are given the vertex and another point on the parabola, we are able to use vertex form to write the equation of that parabola. If we do not know the vertex, we can use three other points on the parabola to write the equation in standard form, and that's what we're about to do in example 1. Here in example 1, we are told that a parabola contains the points 0, 0, -1, -2, and 1, 6. What is the equation of this parabola in standard form? So first thing we want to do is substitute the three xy coordinate values into our standard form, which is y equals ax squared plus bx plus c, to write a system of three equations. So hopefully you still recall how to use a system of three equations and use matrices to solve, and that's what we're about to do. The first thing that we want to notice is that one of the points on the parabola is the origin, 0, 0. And remember, the c value in standard form is the y-intercept. So in this particular case, the c value we already know is 0 because that is the y-intercept, which is the y-coordinate of the origin. This will not always be the case. So the process I'm about to use for example 1 is the process that you want to use whenever you're given any 3 points on the parabola, and it doesn't have to be the origin for one of them. So as you can see, I took the first coordinate point, which is the origin 0, 0, and I substituted it in for the standard form of the equation. Notice that I am putting the y on the right side because I want that to line up with the form of the matrices that we use. So for my first equation, I have 0a plus 0b plus 1c is equal to 0. So as I mentioned, we already know the c value is equal to 0. So I'm going to do the same kind of setup for the next part. So I'm going to substitute in -1 for the x and -2 for the y, just given the xy coordinate, -1, -2. And then from there you just want to simplify, so we have 1a minus 1b plus 1c equals -2, and that's our second equation for the matrix. When substituting in the last coordinate 1, 6, I get the simplified equation of 1a plus 1b plus 1c equals 6. Now I'm going to set up my matrix and then use the RREF, or the reduced row echelon form button on the calculator to solve. So hopefully you agree with my matrix setup here. Just to recall and remind you that you just take the coefficients of the ABC values and the constant on the other side, and you set it up just in order of the three equations. So now let's go to our calculator. Make sure you have that out with you and you're working along with me. And I will remind you where to go. You want to go to second matrix and then over to edit. And make sure your matrix is a 3 by 4 because there are 3 rows and 4 columns in this specific matrix. So if you already have that set up, you can just write over your previous matrix, or you can feel free to use a different letter. You don't have to use matrix A. So let's take a moment and type in our coefficients and constants. Make sure you press enter after each value. Once you have your matrix inputted, you want to go to second quit and then back to second matrix, go to math and down to reduce row echelon form, which is RREF, and then go back to second matrix and input your matrix A or whatever variable you used. And you can see here that we have our values for A, B, and C. They were 2, 4, and 0. And that agrees with our original hypothesis that the c value is equal to 0. So now that we know our values for A, B, and C, we can input those values in for our standard form. So we have the equation y equals 2x squared plus 4x, technically plus 0, but you don't need to write that. So this is the equation of the parabola that contains the given points that we were given at the very beginning. Example 2 is a real-life application problem. It says, campers at an aerospace camp launch rockets on the last day of camp. The path of rocket 1 is modeled by the equation h equals negative 16 t squared plus 150 t plus 1, where t is the time in seconds and h is the distance from the ground, also known as the height. The path of the rocket 2 is modeled by the graph at right. Which rocket flew higher? So for rocket 1 we have the equation, for rocket 2 we have the graph. So now we need to figure out which of those two rockets flew higher. If we want to find out which rocket flew higher, we need to figure out the maximum height of each of the rockets, which is also known as the vertex. And we know that since the leading coefficient, the a value in the given equation, is a negative, and the graph is opening down, that they're both opening down. And that makes sense when you launch a rocket. That would be an upside down parabola. So we want to figure out the maximum height, aka the vertex, and then compare the y coordinates of the vertex to figure out which one is higher. So first thing we want to do for rocket 1 is rewrite the equation and identify the a, b, and c values. So here we have the a, b, and c values as negative 16, 150, and 1 respectively. And hopefully you recall from a previous lesson video that in order to figure out the vertex, we can take the negative b over 2a. That will give us the x coordinate, or in this case the t value, since the input value is time. So let's take a look at that and plug in our values. So our x coordinate, or our t coordinate, should be negative 150 over 2 times negative 16. And when you multiply and divide that, you should get 4.7. So that would be our x coordinate essentially. And then to figure out what our y coordinate should be, we just need to input the 4.7 in for the original equation. So when substituting in 4.7 for the t in each of those places for the original equation, you should get a value of 352.6. So this is the coordinate of the vertex of the first rocket. And you can take a look at the y coordinate, essentially the 352.6. That would be the max height of the first rocket. For the second rocket, we're given the graph shown at right, and for this process, we're actually going to have to estimate or approximate the maximum height of the rocket because we're not given the equation, we're just given the graph. So you can see in this graph that the vertex is approximately at the coordinate 6, 580. So that means the max height of rocket 2 would be approximately 580 feet. So based off of these two max heights, we can see that the second rocket flew higher than the first rocket by approximately 230 feet or so. In this example, we're going to learn how to use the quadratic regression feature on our graphing calculators to find a quadratic model for our data. And this is best used when we have more than 3 data points that suggest a quadratic function. So you can see in the table that we're given, the predicted temperature values they're increasing and then they're decreasing. So that suggests that it's not a linear function, but rather it may be a quadratic function. So now let's take a moment, pull your graphing calculator out again, and we're going to input these values in for our stat data, and instead of using the linear regression feature that we used in the past, we're going to be using the quadratic feature. In example 3, we have a table that shows a meteorologist's predicted temperatures for an October day in Sacramento, California. First thing we need to do is come up with a quadratic model or an equation for this data. So now that you have your calculators out, let's take a moment and type in our values. So turn it on and go to Stat, Edit, and you can clear out your data values from the previous problems that we've done in the past. So go up to the title of the lists and press clear and down arrow. And you can input the time values in for the X, or the input column, just as shown. For our times afternoon, we're actually going to be using the military time or the 24-hour clock to represent the times afternoon. So after you type in 8, 10, and 12, for the rest you want to type in 14, 16, and 18. So I'm not sure if you're familiar with military time, but they use this to indicate the number of hours after midnight. So this way we won't be repeating input values for AM and PM. So we have our X column identified, and now let's type in our temperatures for the Y column. Okay, so now we have our data entered into our table, and we want to go to Stat, Calc, and the one below linear regression is quad or quadratic regression, so press Enter. I believe your calculator asks for what lists you use, and hopefully you just use list 1 and list 2, so it's default set up for list 1 and list 2. So press Enter, and now you can see the values for A, B, and C. And then the r squared value, since this is not a linear function, we use the r squared to indicate the accuracy, and that is very close to 1, so that means that we do have a pretty good fit for our quadratic data. So let's take a moment to write down this equation that we're given, and then we will graph the data and the function as well to confirm that we did the right thing. Rounding these values to 3 decimal places, we get the equation for this quadratic model as y equals negative 0.469x squared plus 14.716x minus 36.121. Now let's go back to our calculators and graph the data points as well as the regression equation. So let's graph the data points first. So go to second stat plot. And you can see right now that all my stat plots are turned off, and the default is list 1, list 2, which is currently what we're using. So press Enter and then turn it on. And then press second quit. Now you can go to y equals, and it looks like I have an equation from a previous lesson video, so you can press clear to that. And now let's type in our regression equation. Okay, now that we have that inputted, let's check out what the graph looks like. And it looks like my window's not so good. So let's go to window. And yeah, that's really, really big. Let's change that to more like 100 for each of those maxes, y and x. All right, now let's go back. Okay, and we can actually zoom in a little bit more, so I can change my x max to 50, and let's see what that looks like. Okay, so you can see that our regression equation is a pretty good fit. If we zoomed in more, we probably would see a little bit of error, but overall, I think we did a good job. Part B is asking us to use our model to predict the high temperature for the day. At what time does the high temperature occur? So let's go back to our calculator and go to the maximum feature, because if we're looking for the high temperature of the day, that means we're looking for the max value or the vertex. And you can see that the parabola is opening down, so our vertex is called the maximum or the highest point of that parabola. So let's go to second calc and down to maximum, press enter. Now choose a point on the left side of the vertex, press enter. Now go over to the right side of the vertex. Choose any point on the right side, press enter, and then one more time enter. And now we're going to get a maximum value of approximately 15.69. And then that's our x value, and our y value is approximately 79.3. So let's take a moment and write that down and interpret our results. So as we discussed, the vertex of the maximum point is at the coordinate 15.7. comma 79.3, and this is approximate or rounded. So to interpret that, we can say that we are predicting that the high temperature for the day will be about 79.3 degrees Fahrenheit, so that's the y-coordinate of this vertex maximum point, and the time is approximately 3:42 p.m. Now you're probably wondering, where is that number coming from? Well, our x-coordinate is the 15.7, and remember, that number indicates the number of hours after midnight. So that would be 15.7 hours after midnight. So I know the 15 part, that means it's going to be after 3 p.m. because if 12 is at noon, then 3 hours after that would be at 3 p.m. And then the 0.7 I just figured out by multiplying 0.7 times 60 because there's 60 minutes in an hour. So when you multiply 0.7 times 60, you get 42. So that's where that 3:42 p.m. is coming from. That completes the lesson 4.3 video. I hope that you benefited from it and learned a lot of real-life applications and the usefulness of quadratic functions. Take a moment to jot down these 3 lesson check problems and make sure you complete them.